Introduction to Deep Learning. Workflow of a machine learning project. Good day, everyone. Today, we will explore the vibrant world of deep learning, focusing primarily on the workflow of a machine learning project, spanning from data collection all the way to model deployment. The very first step in any machine learning workflow is defining the problem. This is where we decide on the predictive or classification nature of the problem. Our choice here will guide the rest of our project. Next up, we collect or generate a dataset for the problem. This might involve scraping websites, conducting surveys, or using pre-existing datasets. Remember, data is the fuel for our machine learning engine. Data pre-processing is an essential part of our workflow. This could include tasks like normalization, dimension reduction, and handling missing values. Good pre-processing can make the difference between a mediocre model and a great one. In data pre-processing, we create separate training, testing, and validation subsets. These allow us to more effectively train our models and assess their performance in a controlled way. After pre-processing, a suitable model is chosen. This might be a pre-existing model, or we could create a custom-made one. The choice depends on various factors, including the structure of the data and problem requirements. Neural networks, a type of model used in deep learning, can behave like a black box. This can make it challenging to interpret their functionality. However, they are extremely powerful and flexible tools for prediction and classification. The chosen model is then trained on the training subset of the data. This involves feeding the data through the model and adjusting the model's parameters based on the output. Training mechanisms may involve backpropagation, where prediction errors are used to refine the model's parameters. During model training, epochs and batch sizes become critical. Epochs are iterations over the whole dataset, while a batch size is the number of training examples used in one iteration. Careful choice of these parameters can significantly speed up training. A validation subset of the data is used to tune the model's hyperparameters. This helps prevent overfitting on the training data and optimizes model performance. Hyperparameters can include learning rate, epoch number, batch size, neural network architecture, and choice of optimization algorithm. Once training is complete, it's time to test the model against the testing subset of the data. This step helps verify the model's performance on unseen data, giving us an unbiased assessment of its predictive capabilities. Evaluation metrics such as accuracy, precision, recall, or mean average precision, MAP, are used in the assessment of model performance. Based on these metrics, the model might undergo tweaking and optimization to better its results. Overfitting is a significant challenge in deep learning projects. Techniques such as dropout and early stopping can be employed to prevent our model from learning the training data too precisely and failing to generalize to unseen data. Once the model is fine-tuned and achieves a satisfactory performance, it's time to prepare for deployment. The deployment process will depend on the end use of the model. Deep learning frameworks like TensorFlow and PyTorch offer a wealth of tools that assist in creating, training, and deploying models. Regular updates and maintenance of a deployed model are crucial. Models should be updated as more data becomes available, and their performance should be regularly evaluated to ensure they continue to meet the requirements of the problem they were designed to solve. Python has become the language of choice for many deep learning projects due to its simplicity, large set of libraries, and strong community support. It allows for quick prototyping and has APIs for most deep learning frameworks. The world of deep learning is complex and exciting, with a nuanced workflow and remarkable results. By understanding and mastering this workflow, you can create impressive models that offer powerful predictive and classification capabilities. In our next class, we'll examine specific deep learning models, diving into the architecture of neural networks and how they can be optimized for various tasks. Stay excited and keep learning.